Testing. Hello, hello, Hunter. People in the back, bring it in, bring it in. Reel it in. Grab a slice and grab a seat. A lot of cool kids in the back, but a lot of open seats in the front. Should we get started? Welcome, welcome everybody to the first meetup of Rocky Mountain Blockchain in who knows how long? Years? Decades? I can't even remember anything before COVID. This is definitely the first Bitcoin meetup or Bitcoin topic related meetup we've had since I can remember. This meetup actually used to be called Denver Bitcoin Meetup. And I think that was started in like 2015 or 2014. But by 2016, all the topics were non-Bitcoin. And we said, well, why don't we rename it Rocky Mountain Blockchain? I don't remember. We had a speaker come in for like Monero or something to the Bitcoin meetup. And I was like, oh, maybe we should have a more inclusive name. So we did that. And I think, honestly, this is like the first Bitcoin topic-related meetup we've had in like 5 years, maybe longer. Matt and I were going to lunch, and he told me how excited he was about what Start9 was doing in the Bitcoin Lightning node space. And I said, Bitcoin Lightning? Is that a thing? And he said, yeah, a lot of people thought it was vaporware, but that was like 3 years ago. People are actually using it now, and it's real. And I said, I forgot. I forgot about this thing. And he said, well, you better learn your stuff, because it's real. And that's how this meetup came to be. Start9 then graciously offered to sponsor this. So before we go too deep, Matt, why don't you tell us what Start9 is?
So Start9, in the broadest sense, is a computer company, a new kind of computer company that aims to disintermediate personal computing for individuals. What I mean by that is that we make running a personal server accessible to the average individual. So with our technology, both our server and our operating system, you can, regardless of technical expertise, essentially, not fully, but getting better every day, de-Google your life. Right? You can do things like text messaging and cloud data storage, or running your own Bitcoin node, or personal password management. And you can do all of it without any third-party participation. So it's a little black box, you plug it into your home. It serves itself up as a website on the darknet, which you can then access from anywhere in the world. We actually don't like the term darknet. Private net is better. And so from a browser, from anywhere in the world, you can talk to a black box in your home and use it as a personal cloud device that is capable of running basically any variety of self-hosted open source software. Now, this has always been possible, but it has been only available to people with resources, technical expertise, money, and a lot of time on their hands. Because running self-hosted open source services on a box in your home and serving it over Tor is, quite frankly, inaccessible to most people. We have made that into a graphical user interface operating system that is plug and play, point and click, and you're up and running. And it manages all the technical aspects of it for you. So that's what we do. And as a major part of that, it's Bitcoin and Lightning, which are two things that people very much want to run on their own box, and in the future we will also be able to run other cryptographic and blockchain network nodes as well. So.
Thank you. Can a dummy like me spin up a Lightning node using your tool?
It's like 3 clicks.
3 clicks, and
Managing it's harder.
if I want to buy one of your devices, where do I go? Start9.com.
Or you can buy one from us here because we have some.
Or they got some in the van behind us. Just kidding. All right, before we hand it off to our main speaker, I want to do what has become tradition. Look around and find someone you haven't met before. Introduce yourself. Tell them why you're here. Go. All right, let's reel it in. Let's reel it in. I know, they're interesting, right? That's why I asked you to meet them. They're all good people. Bring it in. Oh man, what a rowdy crowd. What a rowdy crowd. It's been years. It's been years. But we've got Keagan here, and we've got Lightning. All right, I'm gonna go old-fashioned here. If you can hear my voice, clap twice. If you can hear my voice, clap once. If you can hear my voice, clap 3 times. It worked. It worked. That was it. That was it. 3 fingers. I don't know what that means.
It's a kindergarten slang. Different.
All right. Now, our speaker, Keagan, who is Chief Lightning Network Officer at Start9 Labs. Here we go.
Thank you, Sasha. All right, so as Sasha said, my name is Keagan McClelland, at Proof of Keegs on Twitter, and I'm here to talk about the mechanics of the Lightning Network. Before we get started, a quick show of hands, how many people here are familiar with how Bitcoin works at kind of the chain layer? Fantastic, okay. Of those of you who aren't, can you raise your hands if you're new? And okay, and then are you familiar with any other blockchain networks? Okay. All right, so before we get it started on how to talk about what Lightning is, what we first have to understand is what it was designed to do. And the fundamental question that we're asking ourselves right now is, how do we scale Bitcoin? And what we mean by scaling is that we want to be able to add new users to the system and have them being able to get the same user experience as everyone else. And we want to be able to increase the amount of transaction throughput to offer more service to the people who do use it. So we're increasing the bandwidth of the service provided at a rate that is faster or equal to the costs imposed on the providers of the infrastructure. This can be accomplished in a couple of ways. Either by adding users to the system, we can they can bring their own resources to run it, or by adding small increases in the resources used, we can get outsized scale or outsized output out of the system. So what services does Bitcoin offer? It offers ledger space to track ownership. We call this the UTXO set. And it offers the ability to transfer ownership of coins via transactions. And this is typically quoted in TPS for Bitcoin and other systems. And what cost does it impose on who runs it? Well, you have network bandwidth for transaction and block propagation. So every time you need to forward transactions to the broader network, it uses network bandwidth, and same with blocks. It requires CPU time for validation so that you know that the transactions and the blocks that are coming in are valid with respect to the consensus rules that you are choosing to follow. And it requires the storage of the historical data if you wish to keep an archive, but at the very least, it also requires storage in the form of the UTXO set, the current ledger state. And are these problems unique to Bitcoin? No, not at all. These services and costs are true of all systems that use blockchains as their core data structure. And so we need to talk about what a blockchain is and why it doesn't scale. It is a fully replicated database. Every participant has a copy of the entire ledger state. At the UTXO set at a minimum, most of them also have significant amounts of block history as well. State updates are, which are just transactions, are delivered in batches, which are blocks, over the network, and all the transactions are validated by every node. Every node independently computes the results of the state update. And then typically, most networks have some sort of limitation on the amount of the data or computation that can happen over a given unit of time. This is the block size in Bitcoin, as well as a few other parameters like the SIGOPS limit in the script, as well as the gas limit in Ethereum. So from these things, we should be able to see why it's not actually possible to scale a blockchain. And that is because as you add participants to the system, you're not actually giving the system more throughput. You're actually amplifying its costs. Now, those costs are generally justified because the people who are getting added to the network are getting their own security for it, but it doesn't increase the amount of service that can be provided. So obviously, the question is, what if we increase the block size? And so we can get a transaction throughput that goes up by a fixed amount, right? So if we 2x the block size, then we can get 2 times the number of transactions through. But this doubles the costs for all of the participants, which means the aggregate resource spend is absolutely massive. Network bandwidth actually goes up even more than 2x because of the nature of the peering relationships, where it scales with the number of cords between the participants. And then storage cost goes up for all participants, as well as CPU. So if we can't just increase the ledger size, what can we do? What's the important thing that needs to happen? And the answer is that we need to compress economic information into smaller byte space, in particular in Bitcoin. And this, if you were using a different system for evaluating the finiteness of the resources, like Ethereum, you would need to fit more economic information into the gas limit. So what's the Lightning Network? It exploits what is like an algebraic equivalence between the sets of transactions. And what I really mean by this is that transactions can be combined into smaller, large numbers of transactions can be combined into smaller, or into a single transaction. So if Alice sends Bob 2 Bitcoin and Bob sends Alice back 1 Bitcoin, you could express the combination of those transactions as just Alice sends Bob 1 Bitcoin. And similarly, if Alice sends Bob 1 Bitcoin and then sends him another Bitcoin, you can net that out in the form of a 2 Bitcoin transaction. So we can compress these greater numbers of Bitcoin transactions into a single transaction at the end. So, and we can represent them as like the sum of the transactions, where money sent might be negative and money received is positive, and it's the opposite for the person on the other end of the transaction. So, with that as background, we can talk about the design of the Lightning Network itself. And the fundamental building block that we use in the Lightning Network is a construction we refer to as a payment channel. And a payment channel is a private ledger between 2 parties. It's a vehicle by which the parties can maintain a state between them where they transact as many times as they want and net out the results in a single Bitcoin transaction. We can compress an infinite number of transactions between these 2 parties into a single transaction, because if they're just sending money back and forth over time, eventually you can settle all of those transactions in a single one, almost. The problem with this is that if you are only wanting to settle this out in a single transaction, say like a bar tab, when you go into a bar, you might open a tab at the beginning of the night, and then there's one transaction that takes place at the end, which nets out the sum of all of the drinks that you've purchased. However, one of the properties of cryptocurrencies is that there are a few properties that make this impossible to do in a single transaction. Number one is that they're self-enforcing. They need to work independent of any court system to enforce whatever agreements are happening. They are permissionless, which means that new accounts can be created for free. All this results in the fact that debt becomes insecure, and so we need to make these solutions liability free. If they're not liability free, then you can simply just default on your debts, and then the system doesn't actually work. So how do we make liability free payment channels? Well, we have to commit funds upfront to the payment channel, which requires one transaction. The total net flow of funds between the parties can't exceed the initial commitment, which, as an example, if Alice commits a Bitcoin and Bob commits a Bitcoin, Alice can send a Bitcoin to Bob, but Alice can't send any more Bitcoin on this channel until Bob pays her on this channel. And this commitment, or this limitation of not being able to send more than the money that you have on your side of the channel, is going to be important later in this presentation. So how do you pay people besides your counterparty? If you have a payment channel, it clearly allows us to make progress against scaling goals with a single person, but how do we create this to make this construction into a broadly usable payment network across the world? Because this arrangement as is kind of limited, and if you can only commit funds up front, do you need to have transaction or channel relationships with everyone that you transact with? The answer is no. But in order to determine that, we have to get into the guts of Bitcoin itself. So how is money sent in Bitcoin? This is actually something that is not, this particular design of Bitcoin is different from a lot of cryptocurrencies. It's also the same as a lot of other ones. We use something called the UTXO model. And what that means is that transactions reference specific coins that you are trying to spend as inputs to the transaction. And then the spending conditions of those inputs must be met by what is called a witness. And typically a witness is comprised of a digital signature. Most of the time when you are sending Bitcoin, you're mostly just putting a digital signature on the transaction, and that constitutes the witness. But a witness is any solution to a problem that is outlined in the spending conditions. Transactions create specific coins with new spending conditions. So you have a bunch of inputs with a certain amount of value attached to them, as well as their spending conditions. You have the witnesses attached to those inputs, and then you create outputs with new spending conditions. You can use an arbitrary number of inputs. You can create an arbitrary number of outputs, and the value of the inputs must exceed the value of the outputs. This is how you prevent people from creating more money. So with that, here's a diagram that kind of attempts to show how that looks. I'll let you ingest that for a second. All right, so what is a payment channel? And because we famously don't have smart contracts in Bitcoin. A payment channel is actually a 2-of-2 multi-signature output. All a multi-signature transaction is it's a form of script that requires a signature from both the parties who are on that particular multi-sig agreement in order to be able to spend it. Now, this should be concerning unless you already know how Lightning works. If you are about to send money to a 2-of-2 multi-signature transaction, or to a 2-of-2 output, how do you get that money back if the person on the other side of the channel stops cooperating, goes unresponsive? Like, is that money black holed for eternity? No, because it wouldn't work if it did. So if your counterparty goes offline, that's a problem. And if they disagree about how much money that they owe you back, you can't get your halves. Because if you notice in this diagram, each of the parties are committing half a Bitcoin, but they both have to agree on the spending. So if Bob says, nah, Alice, I don't think you get 0.5 back. I think you get 0.3 back. That's also going to be a problem. So we need to figure out how you get your money back. So the way that this is accomplished in Bitcoin is with something called a commitment transaction. A commitment transaction is signed before the money is deposited into the 2 of 2 multisig. And what it does is it pays both the counterpart or both of the parties on the system or on the contract back their original amounts that they are committing. So in this diagram, the commitment transaction would pay Alice back 0.5 Bitcoin and Bob 0.5 Bitcoin. The reason for this is that, you know, if you have a commitment transaction that is signed by the other person before you put the money in, then you can always guarantee that you'll be able to get your money back out if they stop responding. It's got 2 outputs, 1 for each participant, and each channel state has 2 different asymmetric commitments. And we'll get to the specifics of the commitment transactions in a second. But the reason that they're asymmetric is that Alice's commitment transaction is signed by Alice and given to Bob, and Bob's commitment transaction is signed by Bob and given to Alice. Here's a diagram of what that looks like. I've covered up some of the parts that I'll be talking about later, but you can see that Alice's commitment will pay Alice half of a Bitcoin back and Bob half a Bitcoin back, you know, barring some other stuff that's about to happen. And Bob's commitment does the same, but in reverse. Yeah, so it's important to note that each commitment transaction is a mirror image of your counterparty's commitment transaction. So if you swap the keys and the amounts on every Bitcoin or on every commitment transaction, you get the commitment transaction of your counterparty. And this is all so that we can work with people who we don't necessarily trust. So Alice's commitment is signed by Alice. It's given to Bob. It allows Alice to spend her funds immediately. And it requires Bob to wait for some period of time to allow Alice to contest the commitment. And we'll get more into why this is in a bit. If Alice can successfully contest this transaction, or like the commitment transaction, she gets all of Bob's money in addition to her own. And after the contest period, Bob can claim his money. Bob's commitment is the same exact thing, except it's in reverse. And so all of this revealed in diagram looks like this. The reason for this asymmetry will become apparent when we start to talk about how these channel states get updated over time. So how do we send money over a payment channel at all? Now that we have these commitment transactions, we can basically close the channel where we're at, or like end this particular contract relationship. But now we want to be able to extend it. We want to be able to change the amounts that are paid back to each person. And we want to do that in a way that doesn't leave anybody out of the money that they're owed. So we have something called a hashed time-locked contract. It's hashed because the sender can make a payment that is conditional upon the receiver being able to reveal a pre-image of a hash. It's time-locked because the sender can reclaim the payment if the receiver fails to reveal that pre-image in a certain period of time. And this is what prevents the sender from losing funds to an uncooperative or unresponsive receiver. And then it's a contract because the terms are enforced by the Bitcoin script system. Bit of review, hashes a hash is a one-way function where 2 identical inputs will produce the same output, but it is impossible to figure out what the corresponding input is by looking at the output. So it's basically like a riddle that can only be solved by someone who already knows the answer. You can't solve for it. So the payment life cycle of a hash time lock contract is such that, and I'll have diagrams that will show this later. So I'm just going to go through the steps in prose first, and then we'll see some pictures about how it works. The sender offers an HTLC, which is the abbreviation for the hash time lock contract. If the receiver accepts, which it benefits them to do so because they're potentially they're going to get paid as a result of it, then an HTLC output is added to the commitment transaction. So you'll see here that if Alice begins with half a Bitcoin, Bob begins with half a Bitcoin, Alice offers 1/10 of a Bitcoin as an HTLC to Bob. you'll see that the way that this commitment transaction looks is that it takes the channel point input as the commitment, which is the sum of all of the money that was in this contract. It pays back to Alice unconditionally 0.4 Bitcoin because it's being deducted from her balance. It pays Bob unconditionally 0.5, which is the 0.5 that he started with. And then we have this third output that gets added to this Bitcoin transaction, which is the funds that are spendable by Bob with the pre-image, or it's spendable by Alice after a certain timeout period. Once this happens, Alice has basically committed to sending Bob this money if he can reveal that hash pre-image in the time period. So at that point, Bob reveals the pre-image because that actually allows him to get paid, and it allows the channel relationship to stay alive. Bob at that point will ask Alice to remove the HTLC output and just put it into his unconditional funds. Alice agrees to this because Bob is guaranteed to get paid either way, because that's how the hash time lock contract works, because he has the pre-image. And she wants to keep this relationship going because why enter into it to begin with if you're not going to use it? So generally speaking, other than technical failures, this will all happen automatically. So what stops me from cheating in all of this? Because now that we've updated channel state, right, Alice only has 0.4 Bitcoin, but she would prefer to have 0.5 Bitcoin. And she still has that old commitment transaction from when the channel got started. So why not just broadcast that? So old commitment transactions are still valid. I might choose to broadcast one where I have more money than whatever the newest commitment transaction is. So commitment transactions, as I said, could be contested by the counterparty providing their signature and what is called a per commitment secret. They can obviously provide their signature because that's how any of this works. But where do they get the secret? So the last part of every state update involves the exchanging of per commitment secrets from the last commitment transaction. So when this HTLC is added, which is a particular state update, or when the HTLC is removed, those are all considered state updates. And the last phase of that means they have to invalidate the previous state by exchanging these secrets. This revokes the state, not because it actually makes it invalid to the Bitcoin network, but because by revealing this secret, you are essentially burning the ships, so to speak, and saying that, all right, if I try to publish this old commitment transaction from this point forward, you have the ability to take all my money in this particular channel relationship. And so channel state is not considered finalized until the previous state is revoked. That is what these particular items on the commitment transaction are. And they're typically the transaction where Alice takes all of Bob's money or Bob takes all of Alice's in one of these sort of violations of their agreement is called a justice transaction. That's just a little fun fact. Okay, so there's one more conceptual leap at this point in order to make a broadly usable payment network. And that is that we need to be able to chain these HTLCs together atomically. What we mean by atomically is that if any HTLC settles forwards, everything in the entire route settles forwards. And correspondingly, if any of them settles backwards, they all settle backwards. And what I mean by settling forwards is that the conditional payment becomes an unconditional payment via the revealing of the pre-image. And what I mean by settling backwards is that the sender is able to reclaim their HTLC funds because they timed out. So how is atomicity achieved? We use the same hash for the whole series of HTLCs. This means that in the process of revealing the hash pre-image of an HTLC, you end up giving your counterparty the necessary information to be able to pull to reveal the pre-image to their counterparty, who reveals it to their counterparty. Let's see this in some pictures. Alice, Bob, Carol, and Dave. Alice is trying to pay Dave, right? So the way this starts is that Dave generates a pre-image and then derives a hash from it. Dave sends Alice the hash, And then Alice uses that hash to construct an HTLC that she offers to Bob. Bob uses the same information in that HTLC to offer one to Carol, who uses that same information to offer an HTLC to Dave. At this point, Dave has an HTLC coming in over to the channel with Carol, but Dave knows the pre-image because he made the whole thing up. And so what he does is he reveals that to Carol and pulls his funds from Carol, and in so doing, reveals the pre-image to Carol, who does the same to Bob to pull her funds, and then Bob pulls his funds from Alice. And now the entire payment has been completed. So this process, if you kind of stare at it long enough and kind of go through the steps, you'll notice that at no point is anyone really able to cheat anyone out of their money, because you can't have someone in the middle stealing payments without the person at the end having already been paid. I was told not to do questions in the middle, so I'm skipping over this. We'll do a bunch of questions at the end. So there are a bunch of DeFi opportunities that kind of that are born out of this particular construction. But the most obvious one is that intermediate nodes become service providers. They provide the ability for you to pay other people around the network. And because becoming a service provider is permissionless, and intermediaries are never trusted with the custody of funds, this is meaningfully different than the intermediaries we have in the financial system today. Like you don't need a bank charter to start a Lightning routing node. Now they might try to set some laws and regulations in this country and others to require you to have licenses, but you can bet that we're all gonna try and fight it. So, and then fees are taken at every hop on the route because they are providing a service, and that service costs them, which we'll get into in a bit. But at that point, that they are compensated for that service by taking fees. So, how does route selection work? How do I figure out like where to send the HTLCs so that they can get to the end and my recipient can get paid? Can we ask our peer to figure out the route? And basically, the way that internet packets are routed is we chuck an IP packet out there and we say like, hey, can you figure out how to get it closer to its destination? And that happens recursively until it gets there. But there are privacy problems with that because then you leak the destination to your peers, and that's not great for a financial network. And we want to maintain that on the Lightning network. So as a result, Lightning payments are source routed. The sender decides on all intermediaries up front and creates this onion packet, which is a nested, you can imagine it as like a box inside a box, or like an envelope inside an envelope inside an envelope, right? Where you send that envelope to the first person in the chain, and that they open the envelope, they get the information they need to set up the HTLC, and then there's an envelope inside that one that they just pass downstream. I have a diagram on the next slide for this. So as a result, each intermediary only knows its immediate predecessor, the one offering them the HTLC, and its successor, which is the information contained in the onion packet. Intermediaries don't even know if they were connected to the sender or the receiver because they have no way to distinguish the endpoints of the payment from anywhere in the middle. Here's like an example of, this is actually stolen from Tor, but it's actually the same basic concept, which is that there's these layers of encryption where each key is unique to each individual hop. So router A, or the blue one in this diagram, can peel the blue but can't peel green, and therefore can't get all the way down to the very end. So this happens all the way to the destination, and it prevents any node from knowing how many hops away from the sender they are or from the receiver. And just another little tidbit is that as a result, there's actually a maximum length of hops that you can go on the Lightning network, which is 20. And this is so that because all onion packets are the same size, regardless of where you are in the route. And the reason for that is that you don't want to be able to infer the destination from the size of the onion packet. because you'll notice this looks like it gets smaller as it gets unwrapped. And there are ways, there are specifically designed things in the Lightning Network specification that actually prevent it from actually appearing to get smaller despite actually getting smaller. So now that we know how to construct a packet to send it to one of our peers, how do we figure out what the possibilities are for the routing? And the way that this is done is through something called the gossip network. So when a channel gets created, so does my node need to know about all existing channels? And the answer is essentially yes. Lightning implementations maintain a full channel graph today to decide on this, which means you have a view of what the entire Lightning network looks like roughly. It's not exact, but you know a pretty high level view of all of the channels that are usable for routing. But how do we learn about new channels? So each time a public channel is created, so every time I open a channel relationship with someone else, me and my counterparty both mutually opt into broadcasting this to the broader network. We say, hey, we want to use this for public routing. And so as a result, we'll both sign this particular gossip message, and then we'll both broadcast that to all our peers. When our peers get that, they'll turn around and broadcast that to all their peers. And the same way that Bitcoin transactions propagate through the Bitcoin network, these gossip packets end up flooding the whole network as well. So over time, every node builds up this graph of what it thinks the channels look like based off of the set of gossip messages they've received. So propagation through the entire network is reached through this rebroadcast process. All right, so there's one other thing to talk about, which is private channels. These are channels that are not broadcast to the broader network. And so if they're mutually opt-in, what happens if we don't opt in? Like, is such a channel even useful? And the answer is yes, otherwise we wouldn't have them. And so the way that these channels get used is a little bit different. By the sender, they're used in a very straightforward manner. Because you are on the channel, it's not private to you. You know of its existence, so you don't need to do anything fancy in order to use it as the first hop in the route. You just offer the HTLC to your peer, you ask them to forward it, and everything's the same as if it was public. So if you're the receiver, it's a little bit different. The sender doesn't know about the receiver's private channels a priori. And so as a result, the receiver has to provide hints in the Lightning invoice. And Lightning invoices are, you can think of them as Lightning's version of Bitcoin addresses. They only work once, the way that you're supposed to use Bitcoin addresses as well. And reusing them is not safe. But inside Lightning invoices embedded these routing hints so that the sender can use that information to decide on the last hop. So the last piece of this is the intermediaries. And so can you use private channels on the intermediate paths? And the answer is no. They're just not usable for that. In fact, that's actually their entire reason for existence, is so that they don't get used in intermediate routing. So you might be wondering, like, okay, I thought one of the exciting parts about Lightning was to be able to route payments so that I could get passive income. And the answer is yes, it is. However, it is important to note that there are costs to that. And that is that you need to be able to maintain balanced channels if you're routing. And the reason for that is that if you are sending money over a channel, there has to be enough money on your side of the channel to be able to send it. And if you're receiving, there has to be enough money on the other side of the channel to be able to receive money on that channel. And the way to imagine this is like an abacus, or if you've played foosball, there's actually a table back there. The way that scores are kept is by moving beads from one side to the other. And when you run out of beads to move to the other side, you can't push any more across that channel. And so as someone who is providing a forwarding service, it involves receiving money on one channel and sending money on a different one. And if there's insufficient liquidity on your side of the outbound channel, or the forwards will fail. This is also true if there's not enough inbound liquidity, or there's not enough money on the opposite side of your upstream channel. But that will fail at your peer instead of yourself. So if you're not going to take this responsibility, private channels are probably what you end up wanting to use, and precisely because they're not used for routing. Keeping the channels private has a couple of benefits, in that if you are not routing, if you're not essentially doing this as a semi-professional, it contributes to the overall network reliability, because if payments fail, because payments will fail if there isn't enough money on your side of the channel, then by not offering it as a possibility in the first place, fewer payments will fail, and then the Lightning Network ends up being more reliable. And then keeping channels private, if you are not a routing professional, means you'll have liquidity reliably where you left it, so that you can use it when you need it. Because as a user of the Lightning Network, you are subject to these same constraints. So that's actually the entire design of the Lightning Network itself. I have a few more slides about like various opportunities and pain points if you guys are interested in hearing them, but I also know that I've taken about half an hour at this point, and Sasha said that I should probably be at 20 minutes. So yeah, ask me, I guess, about those things at the very end. Or yeah, you can ask me now.
Whoa. I'm gonna have to watch that video a few times. Yeah, let's give him a round of applause. That was amazing. We'll do like four minutes of Q&A or 5 minutes of Q&A, and then Keagan's down to hang. So if you guys want to keep chatting and learning, let's do it. If you want to socialize, let's do it. We've got the space for another 50 minutes or so. If it's all right, I'll kick us off with a couple of questions. You mentioned that that we can have as many intermediaries as we like. We send the onion with 20 destinations, even if we're using 3 or 4 intermediaries. If you have to pay each intermediary a fee, why would you use any more than one intermediary?
Not all participants in the network are going to be one hop away. If you can get it there at one hop, you will probably choose that. However, you may choose to choose a longer route if that route is cheaper. All nodes get to set their own fees, and they broadcast those fees to the broader network as a whole. And because of that, you can view a very expensive route as longer than like a series of cheaper routes. So if you have like 3 routes that are going to cost you, the fees are typically quoted in parts per million. So for every million sats that you're trying to send, you might, if you have 3 hops that are all 1 ppm each, you're paying a total of 3 ppm. But if you have another channel that's publicly routable that's charging 100 ppm, despite it being shorter in a like graph theoretic sense, it's longer from a payment sense. So that's why you will, that's one of the examples. And then secondly, you just might not be able to reach your destination in one hop.
Let's do a few questions. We got one in the back.
Yeah, I'll repeat them into the mic.
So this is actually a question is like pertaining to the core and Lightning Network. So I'm not any kind of an expert on core, but there's like nodes within the core network, and then there's like I believe they call them relay nodes, which are like the edge nodes, which touch the clear net. But like you're like kind of not KYC, but you're kind of not really like totally anonymous. So it's important to have. Is it relay nodes? Is that what it's called? The edge nodes?
Okay, so the question is this is a little bit of a Tor question. I can answer it, but it's important to know that this is not for Lightning. Actually, you know what? This question maybe I should. We'll talk offline. What's your Lightning question?
My question is, since like Tor is growing and a lot of people are running Tor nodes in the Tor network, but these other like maybe they're called relay nodes, they not as many people are running them, and they're pretty important because you're not private. So is there like has anyone talked about building an incentive maybe with the Lightning Network to incentivize those nodes as well?
So the privacy guarantee. So the question is are there meaningfully different privacy classes of nodes in the Lightning Network. That's what I understand your question to be. Is that right? Like, are there different, like, are edge nodes different, have different privacy characteristics than the?
And I was wondering if people were thinking about building incentives with the Lightning Network.
Oh, as in, okay. So the question is that are there opportunities to use the Lightning Network to incentivize running of the Tor network? And the answer is there's tons of incentives to run all sorts of distributed services using the Lightning Network, especially things that can be done via incremental payments. So I actually have a few slides on this, but things like network bandwidth you could try to do if you have direct communications with your ISP. You could try to pay them using Lightning for them to actually route your regular internet packets. There are opportunities for like value to value streaming via like video. You can pay for each individual frame if you wanted to. You could pay for each individual second of audio as well. In fact, Breeze, which is a Lightning wallet, has a podcasting app that does exactly this. So you today can pay for individual like 10-second increments of a podcast. And so there are opportunities abound like that. I don't even think that people have thought of all the things that we're going to see in the next 5 years.
I think part of, so I guess the way I would distill all of this is liquidity in the channel, right? Liquidity in the channel has two pieces. One is how much liquidity, higher liquidity comes with more stat commitments to the node, right? And then the other part, which is your question around routing and how fast, how many hops, depends in large part by the fees. So if I want to have, if I've got a lot of liquidity in my node, but I have high fees, you may skip over that and go someplace else on a longer route with less money. So that's, I think, part of what you were trying to describe was, and I think that's also part of your question, there are rings around the network around liquidity. So if you go to high liquidity channels with lower fees, it's the most direct route.
Yeah. So there was no question in there, right? Okay.
No, I was trying to, my question was, is there any way, I run two nodes, and one of the challenges in this is actually visibility of routing. So how to make your node more attractive to run volumes through it.
Yeah. Okay. So there are numerous things about that. So at the very bare minimum, uptime ratios. Like if your node is up a lot, like there are actually a plethora of ranking projects that are going on right now. So the most famous one is something called the Boz score, which is created by Alex Bosworth himself to just try to decide what nodes he wanted to connect to. And then there's a more generalized version of that happening at terminal.lightning.engineering, which is Lightning Labs' attempt at trying to create a ranking system. So working your way up the rankings can make you more attractive to people who are trying to connect to you, as well as having consistently low fees. All of your public channels, people can just look up what your fees are. So like low fees might do it. Being highly connected, people can look up your channel counts. Having good balance, which is having the same amount of inbound and outbound liquidity so that it's broadly usable. And the reason that that's important is if you have a node where you have a whole bunch of what is called inbound liquidity, where it's all of the money is on the outer sides of the channels, you can't route through your node because there's no way for it to exit. So making sure that your balance makes your payment success rate go up, and as a result, you're providing a better service. So the question is, what level of customization can you, as a node operator, impose on your node to, best serve your own needs and what you think the opportunities might be? So you can set fees. And this is one of the most effective ones. You can All of the node implementations offer a way to essentially intercept HTLC forward requests so that you can decide if you want to forward things in and out. Because of the onion packet construction, you can't really tell how early or late in the route you are, and this is actually a good thing. And so you can't really customize like, oh, I only ever want to be the first hop, or I only ever want to be the last hop. But you can use private channels to try to tweak whether or not you want to be using things on the first or last hops, because public channels are the only ones that are broadly usable for routing in the middle. Mm-hmm. A significant, so the question is, the market information, is that freely accessible to everyone? There's a subset of the market information that is freely accessible to everyone. That's what is chosen to be broadcast. But every node has, it is not public information how much money is on which side of every channel in the network. So you're kind of guessing as to whether there's liquidity on certain channels when you are using them. And so that kind of information, if you can get at it, if you can infer it from various probes that you might run, or if a third party is offering that as a service, that might be valuable to you. So there's tons of public information, and there's like a set of information that's less public because people derive it, they figured it out. They might have a particular vantage point within the network from which they can see certain things that you might have a different view. And so being able to aggregate some of that information might help you. Okay, so the question was that due to the design of the Lightning Network requiring this liveness in order to be able to use, do you think that it will incentivize significant amounts of custodial relationships and subsequently harm Bitcoin's self-custody properties? There's a good chance that's true, but the reason that our company even exists is to actually fight that exact problem. That is something that we noticed when we were setting up our own Lightning nodes, which is that, like, you know, Matt, so I had set mine up, and, you know, it took me about 3 days. I had worked in Bitcoin for a couple of years before that. I actually didn't think anything of it, but when Matt was setting his up, he just, I was helping him, and he looks to me, he's like, nobody's going to do this. And so that actually birthed Start9, the company. Oh, are we at it? Okay, I will take as many questions more in a more offline context, like we'll turn off the cameras and stuff, but yeah.
Yeah, I want to ask this question because for me this was really an intellectual exercise. If I actually want to experiment on the network right after this, what do you recommend I do? If it's a Start9 product, what do I do to get started? And maybe we could close on that.
So our flagship product is the Embassy, which is a plug and play personal server, as Matt had mentioned. Installing Lightning is about 3 clicks. Yeah, and at that point you will be able to go through and navigate to those dashboards and then get started right away. There are instructions in these individual applications to be able to engage with it. And I don't know if a demo is appropriate for this forum, but we have plenty of videos talking about it. So the question was how does the justice transaction get relayed if it spends the same UTXOs as the commitment transaction? The answer is it doesn't spend the same UTXOs as the commitment transaction, which if I can get back to the diagram, I can show. I have a lot of slides. So this multisig transaction that you see, it creates two outputs. One that is spendable by Alice. So I'm looking at the top one. One that's spendable by Alice, and a second output that is held in this lockup period. So the justice transaction spends that output. It spends this. It doesn't spend this, right? So the commitment transaction spends this thing. The justice transaction spends this one.
So you're talking about there's this procedure we go through to make sure nobody's cheating.
Yep.
And we're generating a lot of transactions and verification transactions. Is there anything more than my private key that I need to keep private in all of this? Like, is there toxic waste that I need to make sure that nobody else reveals so they can steal my channel?
So the question is there any more sensitive information than your private keys? And generally, technically speaking, no, but you have a ton more private keys to manage in Lightning than you do in regular Bitcoin transactions. Normally, all you have is the private key that is associated with like that particular address, and you derive all of your private keys from a particular seed. In Lightning, you also only have one seed, and that generates the private keys that are for the main signatures, the private keys that are the perfect commitment secrets, the private keys for your actual node identity on the network. So one seed still manages everything, and so in that sense, there's only one key, but there are more keys in play than there ever are on Bitcoin Layer 1. Yeah, all of the transactions are safe to publish at any time. Well, sorry. If you broadcast old commitment transactions, that is unsafe to do. But you can delete those. Yeah. Correct. But that only becomes toxic waste if you publish it, and the only person who can punish you for it is your peer. It's not like a third party can learn of this transaction and hurt you for it. As live as you possibly can. You cannot receive money or forward payments or send money, for that matter, if you're not online. It's always true, even in Bitcoin Layer 1 for sending. It's not true for receiving, because you can just post an address and then, fall off the face of the planet, come back 10 years later, and the money will be there. But yeah, forwarding payments and receiving payments require liveness, which is different from Bitcoin Layer 1. The reason for that is that you have to be able to accept the HTLC, you have to be able to update the commitment transactions, and then you have to reveal the hash preimage, and then update the commitment transactions with the unconditional output.
Excuse me, could I have your attention for 1 second, please?
I can't.
I can't whistle loud. All right, hey, real quick. So for those of you who asked a question, we have 5 of these. I think maybe 6 people asked a question, so it'll be the first 5 who get up here. But basically, this is a magazine, a one-time thing that was printed by Vlad Castilla. He runs the Bitcoin Takeover podcast from Russia, I think he lives. Anyway, this is an 80-page extremely impressive set of articles that explain everything from Bitcoin's block size wars that took place a few years ago to how Taproot works to information about Lightning. It's a pamphlet, magazine, special edition, kind of one-time thing that'll ever be printed. So if you asked a question, we have 5 of these to give out. Come on up and take it. Auction. Sure. Vlad would appreciate it. The money will go to him, not us. 10 sats. 10 sats is the current bid. The problem with an auction is that we will have to do it. No. So we have these and we have these here. I'll tell you what, look, if you want one of these could be a collector's item at some point in the future. They're specially made for this meetup in Denver. He put a special little thing on it just for this meetup. So if you want one and you would like to support him in further efforts to do this, come up and pay for it. We take payment in Bitcoin. And I'll send it directly to him so that he can keep doing stuff like this. Yeah, okay? So they're for sale right now, as are some servers, if you'd like a server.